Between the late 1950s and the 1970s, the Soviet Union quietly launched a series of missions to Mars. These weren't science projects, they were acts of war-level secrecy, covert operations masked as peaceful exploration. Some of them didn't even have names, just numbers, codename after codename, file after file, hidden behind closed doors. And nearly every one of the missions failed. The probes either crashed, exploded, or vanished in the cold vacuum between Earth and Mars. But these weren't minor failures, they weren't test runs, they were supposed to be firsts. The Soviets weren't aiming to just catch up with the United States in the space race. They were trying to leapfrog the moon and go straight to the red planet. To be first, to own Mars. And they were close, much closer than many people today even realize. One probe may have actually landed years before NASA even got near the surface, but no one ever confirmed it. The data? Gone. The mission? Denied. Just another ghost in the Soviet space archive. For decades, these missions were erased, scrubbed from news reports, kept out of textbooks. Even today, many of the photos and documents from that era remain locked away, lost or forgotten. But they happened. To the Soviets, getting to Mars was an opportunity to beat the United States at something they hadn't attempted before. By the late 1950s, the USSR had sent the first satellite into orbit. They put the first man into space. And while the Americans were still figuring out how to get off the launch pad, the Soviets had their eyes locked on Mars. But they didn't want anyone to know how badly they wanted it, because if they failed, no one could know. Failure in the Soviet Union space program wasn't just a technical hiccup, it was humiliating. And in the Cold War, humiliation could mean political collapse. That's why every mission to Mars, every secret probe, every silent launch, every lost spacecraft was locked under layers of classified paperwork. Most of these missions didn't even get a public name until decades later. They were internally designated as Mars 1, Mars 2MV, Cosmos 419, vague names attached to vague hardware, launched with no announcements and buried when they failed. But why all the secrecy? Because Mars was a propaganda weapon. Both the USSR and the United States often downplayed or withheld information about failed space missions to maintain a perception of technological superiority. If the Soviet Union could reach Mars before the Americans, they could claim dominance over the solar system. And the more invisible the program was, the more power they had over the narrative. When something exploded during launch, they reclassified it as a generic Cosmos mission, a catch-all name used for Earth-orbiting satellites. This allowed them to sweep their Mars failures under the rug and pretend they were routine Earth orbit tests. To the outside world, it looked like nothing happened. But inside the Soviet Space Agency, it was chaos. Engineers working around the clock, hardware rushed out the door, technology barely tested, and deadlines imposed not by science, but by politics. They were in a race and cutting every corner they could to win. No backup systems, no redundancy, and no room for error. The ultimate goal: to be the first to reach Mars, land, transmit data, and claim the planet for the USSR. But as you're about to see, that big ambition came at a heavy price. Over the next decade, they would launch mission after mission, sometimes within days of each other, risking everything for a shot at the red planet. Some never even made it off the launch pad. Others vanished in space. One of them may have touched down, and it's very possible there's a tiny Soviet robot buried in the red sands of the Martian planet. But before we get ahead of ourselves, let's start at the beginning. It started in the shadows. The year was 1960. The Soviet Union had shocked the world with the launch of Sputnik just 3 years earlier. The technology was primitive, guidance systems were crude, rockets were unpredictable, but none of that mattered. Under immense pressure, Soviet engineers began work on two secret missions, Mars 1960A and Mars 1960B. These weren't their official names, of course. Those names would only come later from Western analysts and declassified files. Internally, they were called 1M spacecraft, short for First Mars. The American press gave them a nickname, Marsniks, a mashup of Mars and Sputnik. But the Soviet government never acknowledged these missions. Why? Because both failed spectacularly. It was October the 10th, 1960. This was the first interplanetary launch attempt in history, a modified R-7 ICBM rocket. The same kind that had once carried nuclear warheads was repurposed to send a small payload across 190 million miles of space. But just seconds after it left the launch pad, the rocket lost control and veered off course. The self-destruct command was sent almost immediately. The rocket and the probe were destroyed. The embarrassing failure was buried. There were no headlines, no press releases, and no footage. To the outside world, it was simply another launch from Baikonur. 4 days later, they tried again. Same mission, same rocket, same goal. This time the rocket made it to Earth orbit, but just barely. Once in orbit, the upper stage failed to ignite, leaving the probe stranded. Within hours, it re-entered the atmosphere and burned up. In Soviet records, the probe was renamed Cosmos 60, a label used to disguise the mission's true purpose. Anyone watching from the outside might think it was just another military satellite test. But inside the Soviet space program, it was becoming clear. Mars wasn't going to be easy. The equipment wasn't ready, the boosters weren't reliable, and the window to launch, only once every 26 months, meant that every failure was a 2-year setback. But the failures didn't stop their determination. In 1962, they tried again, this time with a new generation of spacecraft, new design features, and new ambitions. The mission was more ambitious than before. Now, not just flying past Mars, but studying it up close. Fast forward to late 1962. The Soviets built a new family of probes, codenamed 2MV, or Second Mars Vehicle. There were two versions, the 2MV-4, a flyby spacecraft that would photograph the planet and analyze its atmosphere, and the 2MV-1, which was a lander meant to crash softly onto the Martian surface and send back data. 2MV-4 launched on October 24, 1962, and made it into Earth orbit, but the upper stage failed yet again. The spacecraft never left orbit and was reclassified as Cosmos 21. 2MV-1 launched 5 days later. This time, the rocket exploded mid-flight. These missions were catastrophic failures, public relations disasters that no one was allowed to talk about. Engineers worked in silence. Failure reports were classified, and all the while, a quiet desperation began to build. Would they ever reach Mars? Would any of these machines survive the journey, let alone return data? The Soviets weren't giving up. They couldn't, and so they pushed forward into the most intense period of the Mars program. What followed were attempts that brought the Soviet Union even closer to Mars. But by the mid-1960s, it was no longer just about reaching Mars. It was about conquering Mars. The Soviet Union had already suffered failure after failure, but each disaster only fed their obsession. Behind closed doors, they were working on a whole new generation of spacecraft, refined, re-engineered, redesigned, all under the 2MV umbrella. This wasn't just one type of probe anymore. It was a growing family of interplanetary machines. Let's rewind briefly. Because while the previous launches failed to even leave Earth orbit, Mars 1 actually made it into space. And it was the first Soviet spacecraft to successfully fly towards Mars. It was launched on November 1st, 1962, and this was a big deal for the USSR. For the first time, the Soviet Union had a probe coasting through deep space toward another planet. It didn't just leave Earth orbit, it stayed on course for nearly 124.2 million miles. It was equipped with a magnetometer to study Mars's magnetic field. radiation detectors, cosmic dust sensors, and even instruments to sniff out potential signs of water vapor. It sent back 61 transmissions, and then, just as Mars was coming into view, the probe went silent. On March the 21st, 1963, roughly 106 million miles from Earth, all contact was lost. No one knows exactly what happened. The most likely cause? A leak in one of the probe's attitude control gas tanks. Without the means to stabilize itself, the spacecraft drifted, its antenna lost alignment, and its power systems probably froze in deep space. Mars 1 was never heard from again. But for the first time, the Soviets had proven they could reach Mars, and that was a huge morale boost, and so they doubled down. The next step was to build something bigger, more improved, more powerful. Zond 2 was launched in late 1964, carrying improved systems and a set of 6 experimental plasma thrusters. This was cutting-edge stuff for the 1960s. It even had an infrared spectrometer to study the Martian surface and detect potential signs of vegetation. For a while, things looked promising. Zond 2 flew toward Mars for nearly 6 months, but then, once again, all contact was lost. Some reports suggest a power system failure. Others point to a thermal control malfunction. It missed the planet by about 1,000 miles, agonizingly close. Another near miss, another ghost probe drifting alone in the void. Still, even in failure, each mission taught them something. The Soviets took that knowledge, made upgrades, and prepared for another push. But between 1965 and 1968, something strange happened. There was a gap, and nothing but silence from the USSR. No public Mars missions, no launches, no press coverage, but behind the scenes, it was all hands on deck. Why this pause in any spacecraft being launched? It turns out that the Soviet Mars team was now preparing for something even more ambitious. Something that would make history if it worked. They weren't just going to fly by Mars anymore, they wanted to go into orbit. And then they wanted to land on the Martian planet. No one had ever attempted this before. But to do that, they needed something bigger. More powerful rockets, heavier spacecraft, more reliable data links, and most of all, a longer burn window to allow precise orbital insertion around Mars. So they took their lesson from the 2MV and Zond series, and in 1969, they launched the most advanced Mars probes the world has ever seen. They were called Mars 1969A and Mars 1969B, sometimes known as the M69 series. But as you're about to see, just because they built the biggest, most advanced spacecraft yet didn't mean they were going to make it into Mars. In fact, what happened next was one of the most explosive disasters in Soviet space history, and no one would talk about it for decades. The Soviet Union had been waiting years for this moment. They had the hardware, they had the mission plan, and they had 2 massive next-generation spacecraft, Mars 1969A and Mars 1969B, each the size of a small bus, and loaded with cutting-edge instruments for imaging, surface scanning, and long-range communication. These weren't just flybys or orbiters. One of them was going to land. If it worked, it would be the first soft landing on Mars in human history. But if you've been paying attention, you probably already know how this ends. To send these probes to Mars, the Soviets turned to their most powerful rocket, the Proton K. This was a beast of a rocket, 190 feet tall, roaring with over 2.4 million pounds of thrust. And it had already proven itself capable of launching heavy payloads into deep space. The launch date, March 27, 1969. Mars 1969A was loaded and ready. The red planet was in position. Everything was a go. The countdown hit 0. Engines roared to life. And then, seconds after liftoff, it happened. The Proton K erupted into a fireball that could be seen for miles. The explosion was so massive, it shattered windows in nearby villages and sent flaming debris hurtling across the Kazakh steppe. Everything, the probe, the rocket, the launch tower, was obliterated. It was one of the largest launch failures in Soviet history. And if that wasn't bad enough, just 5 days later, they tried again. This time, it was Mars 1969B. Same plan, same rocket. And again, it exploded. Not in the air this time, but during stage separation. The upper stage failed, sending the payload tumbling back into the atmosphere and burning up before it could even leave Earth's gravity. 2 multi-million-dollar missions with years of planning, all gone in less than a week. To say the Soviets were demoralized is an understatement. These were supposed to be the crown jewels of their Mars program, a triumphant answer to America's success with Mariner 4 and 6. Instead, the 1969 launches ended in national embarrassment. But what makes this story even more gripping is how hard the Soviet Union worked to cover it up. For decades, these missions weren't acknowledged. When a US mission failed, the world saw it on live television. But in the Soviet Union, secrecy was policy. Only the successful missions were ever revealed to the public, everything else buried. And that means we actually don't know exactly how many Mars missions were attempted. It's believed that at least 6 additional probes, or maybe more, were launched under undisclosed designations, such as Cosmos or Zond projects. These were usually tagged with generic names to obscure their real purpose. Some may have reached orbit, some may have failed at launch, some may have even been destroyed on purpose. All of them were classified. Even today, some mission details remain redacted or lost entirely in Soviet archives. What does that mean for us? It means the early Soviet Mars program wasn't just a race to another planet. It was a shadow war of information, one waged with rockets, data links, and radio silence. But even through the setbacks and silence, the Soviets refused to give up. Because soon they would go further than ever before, and for the first time in history, they'd actually touch the Martian surface. The Soviets made the first physical impact on Mars and sent a signal back. Even if it only lasted for seconds, after a long string of catastrophic failures, the Soviet Mars program entered the 1970s bloodied but not broken. They had one goal: get something on the surface of Mars, anything. And in 1971, they were ready to try again. This time they sent 2 powerful spacecraft, Mars 2 and Mars 3, in a new kind of mission architecture. Each had 2 parts. First, an orbiter to study the atmosphere and take photos from above. And secondly, a lander built to descend through the alien sky and touch Martian soil. These weren't just symbolic payloads. Each lander was fitted with an array of sensors, a soil scoop, a weather station, and, most intriguingly, a small robot rover the size of a lunchbox called Prop M. It had no wheels. Instead, it waddled forward like a clumsy insect on metal skis, dragging behind it a tether to send back data to the lander. This was cutting-edge stuff. No one had ever attempted anything like this before. On November the 27th, 1971, the Mars 2 lander hit the Martian atmosphere, traveling over 13,000 miles per hour. But something went wrong. Its parachute failed to deploy properly. Its descent system never engaged, and it slammed into the Martian planet. However, the Mars 2 probe just became the first human-made object to ever touch the surface of the red planet. It just happened to crash. There was no signal, no data, just silence. It hit the red planet at high speed and vanished without a trace. But this was an historic moment. They had finally reached Mars. Just days later, on December the 2nd, the Mars 3 lander entered the atmosphere. This time the systems worked. The parachutes deployed, the retro rockets fired. The lander made a controlled descent through a raging Martian dust storm. And then, to everyone's surprise and shock, contact. For the first time in history, a spacecraft soft-landed on Mars. The lander began transmitting a signal. The Soviets were really happy. But then, just 14.5 seconds later, the signal went dead. what happened. It was later believed that a massive planet-wide dust storm, one of the worst ever recorded on the planet, may have short-circuited the lander's electronics, fried its antenna, or buried it in fine dust within seconds. Whatever the reason, Mars 3 died almost instantly. But not before doing something incredible. It sent back a picture. Well, sort of. The image was a mess. Just a grey blur with static lines, no clear objects, no landmarks. But that image, blurry and broken, was the first ever transmitted from the surface of Mars. But even if it looked like static, it was history. Oh, and the robot rover Prop-M was never deployed. The Mars 3 lander didn't survive long enough to release it. Somewhere deep in the Martian dust, that tiny robot still sits today. Untouched for over 50 years, a lost piece of Soviet hardware, frozen in time on another world. They tried to conquer Mars before anyone else. They failed, but they were first. Despite this, humanity would soon conquer Mars, and everything we thought we knew about the Red Planet would be turned upside down. Since 2018, the InSight spacecraft has been monitoring earthquakes using the Seismic Experiment for Interior Structure. It recorded more than 1,300 tremors, and compared to Earth, this is close to nothing. We have seismometers that record from 500,000 to 1 million earthquakes every year. Besides, almost all the vibrations on Mars are very weak, up to 3 points. The strongest one at 4.2 magnitude was recorded in August 2021. And then in May 2022, the Red Planet experienced a magnitude 5 Marsquake. On Earth, this could knock out windows in houses and slightly damage our infrastructure. But it was quite a significant event for Mars. Earthquakes are stronger due to displacement of tectonic plates and volcanic eruptions. Mars isn't that active, but the 5-point tremors show that tectonic processes haven't subsided in its depths. Movement and magma bursts continue. When magma rises, it causes the bending of a single lithospheric plate of Mars, which leads to Marsquakes. But does geological activity on Mars bring us closer to solving the mystery of its habitability? We know this planet as a very harsh and inhospitable world, extremely cold, with terrible radiation and no liquid water. And of course, there's nothing like elephants, tigers, or even mice on its surface. They wouldn't withstand such conditions, and we could easily notice some of them with telescopes or rovers. But we wouldn't notice microorganisms with these tools. Microorganisms are able to survive in extreme conditions on Earth, so there's a possibility they could also exist on Mars, especially in its depths, where it's warmer and there's no fatal radiation. Additionally, the discovery of subsurface lakes on Mars is an exciting finding, as it suggests the possibility of liquid water, which is an important ingredient for life as we know it. In 2018, radar instruments on the Mars Express spacecraft orbiting Mars detected a large underground lake on the planet's southern pole, as well as 3 smaller bodies of water nearby. The lakes span an area of over 75,000 square kilometers. This region is located in the Planum Australe, a large ice-covered plain. And in 2022, instruments on the ExoMars orbiter showed there are also giant reserves of frozen or liquid water in the Valles Marineris canyons. They're hidden inside a canyon system running along the equator of the planet. The water in the canyons covers an area the size of the Netherlands. It's located very close to the surface of the planet, within the top 3 feet of soil. On Earth, similar subglacial lakes in Antarctica have been found to contain microbes, fish, and other organisms. This could also be the case on Mars. A small amount of heat is retained beneath the surface of Mars from the planet's interior, but it may not be enough to melt the ice. This means that lakes may be frozen due to a high concentration of salt. If it's 20 or more times saltier than Earth's oceans, even microorganisms would not survive. In order to understand this, scientists are trying to determine the composition of water in the underground lakes. They're also searching for signs of life in dried-up surface water bodies. Once, many lakes and rivers flowed on Mars. The planet was warmer and had an atmosphere. Many different organisms could have lived in such bodies of water, but up until recently, we couldn't find any traces. In September 2022, the Perseverance rover made a shocking discovery. It found organic molecules near ancient water sources. This wasn't the first time that rovers have found organic matter on the red planet, but this discovery is important because it was made in a place of ancient river-lake merger, particularly favorable for life. It's located in the Jezero crater, 45 kilometers in diameter. The delta formed about 3.5 billion years ago and had been accumulating sand, dirt, and salts over time. Perseverance has extracted the largest amount of Martian organic molecules from this mixture to date. On Earth, fossils of ancient organisms are also commonly found in such sedimentary rocks. The Sherlock instrument on the Mars rover Perseverance, which is designed to identify organic and chemical substances, scanned molecules from the Jezero crater. Among other elements, it detected hydrogen atoms linked to carbon atoms. Carbon is crucial for life and may indicate biological activity. It's also important to note that the organic molecules in the Jezero crater sediment are intertwined with sulfates. On Earth, sulfate deposits preserve organic matter and often contain signs of life. However, the molecules in the crater may have formed through natural processes. Scientists will be able to determine their origin more accurately once samples are brought back to Earth, which NASA plans to do in future missions. Meanwhile, scientists have discovered other hints pointing to the possibility of life on Mars. Recently, the Curiosity rover detected an unusually high level of methane on the planet, 21 parts per billion units of volume. So what does this tell us? Methane in higher concentrations is found in the Earth's atmosphere and is formed due to the emissions of living organisms. Researchers are planning to find out if the gas on Mars is also related to the activity of its inhabitants. If the methane had formed a long time ago, it would have already broken down into its component elements. Another possibility may be that the gas is a product of interaction between rock and water. But methane isn't the only gas scientists are curious about. Carbon dioxide, considered harmful on Earth, may soon become invaluable on the red planet. The experimental device Moxy, the size of a toaster, was brought to Mars on board of Perseverance. Its parts were printed on a 3D printer from a nickel-based heat-resistant alloy. Its composition also includes a lightweight aerogel for heat retention and a thin external gold coating that reflects infrared radiation. Thanks to this, the unique device is able to withstand a temperature of 800 degrees Celsius, at which gas transformation occurs. Moxy has recently produced pure oxygen from CO2. It works by separating oxygen atoms from the CO2 molecules. The byproduct, carbon monoxide, is released into the atmosphere. The tool is designed to produce up to 10 grams of oxygen per hour. However, after an hour of operation during the first test, the gas output was about 5.4 grams, enough to let an astronaut breathe for about 10 minutes. The device is particularly valuable because it's virtually unlimited in terms of raw materials, as the atmosphere of the red planet is 96% carbon dioxide. Also, Moxy uses regolith, which covers the entire Mars. After processing, this soil becomes fuel, air to breathe, or, combined with hydrogen, water. NASA and SpaceX CEO Elon Musk closely follow scientists' discoveries on Mars. The head of SpaceX actively prepares for flights and promises that we'll see the first images of astronauts on Mars in 2029. 14 Raptor engines of the Starship spacecraft have already been tested. Meanwhile, NASA has also chosen Starship as the first crewed landing module for the Moon. If everything goes according to plan, astronauts will land on the lunar surface in 2025 or 2027 as part of the Artemis 3 mission. Then by 2040, NASA plans to send a manned spacecraft to Mars, and the Moon will become a base for refueling. But after the flight, the colonists will still have to settle in extremely difficult conditions on Mars, and that's when new discoveries by scientists will come in handy. Most likely, as experts say, the first crew will land near the planet's equator. The canyon, with liquid water in the Valles Marineris, will be the perfect landing spot. Water is necessary for drinking, growing crops, and sustaining household needs. The settlers will also need oxygen, as the air on Mars is composed of a toxic mixture of carbon dioxide, nitrogen, and argon, and Moxy is getting closer and closer to solving this problem. In addition, Elon Musk plans to refuel rockets directly on Mars for the return trip to Earth. To do this, he wants to build a factory on the red planet to produce methane and liquid oxygen from water ice and atmospheric carbon dioxide. If researchers do find microorganisms in the subglacial lakes, it'll also be a step forward to colonizing the planet. Local microorganisms will be perfectly adapted to the harsh conditions of Mars. By studying them, it'll be easier to find ways to protect against the variety of climatic dangers of the red planet. Do you think there was ever life on Mars? Let us know in the comments, and leave a like if you enjoyed this video. And to stay updated on the latest science news, subscribe to the channel. Thanks for watching.